how do we draw a reciprocal function? Well, first of all, let's draw in our f of x. So this is 2x squared minus 4. So it's got a vertex at negative 4. And when I solve the roots, it's going to be about negative and positive root 2. So those are going to be important points. I'm just going to sketch in my graph when x is, let's put x is 2 squared. So it's going to be about 4, somewhere around here. And then I'm going to sketch in my original function. Now this is not the graph that I want. I want the graph of its reciprocal. So how do I find the graph of the reciprocal? So plugging this in, I get negative 2, 4, root 2, 0, 0, negative 4, root 2, 0, and 2, and 4. What's really important is where it crosses 0. So that's going to be the primary important piece because that's going to generate these vertical asymptotes here. And that's the main thing that we have to look for. We've got to look for where we have zeros, and that's where we're going to have asymptotes or undefined values. So this is the key. That's the most important piece of drawing a reciprocal. The other part is we need to just find the reciprocal pattern. So as the red graph goes away, we're going to move towards the x-axis and vice versa. It's going to go up the asymptote. And we could plug some points in here. You know, we could do a reciprocal point here. It's going to be at 1/4. And it's going to be symmetrical here. There is some invariant points at y equals 1. So if you can find those are great. Okay, these invariant points. I'm not going to be too picky about those because some of these are very hard to find. But the vertex here, we can take the reciprocal of the vertex. So we get negative 1/4. And we can plot in a few points. But again, we know that it's going to go along the asymptote to the vertex. And then go back along the asymptote. Okay, and notice that as we cross the asymptote, the positive part stays positive. It points up to positive infinity. The negative part stays negative and points down to negative infinity.